Sohcahtoa, right? In this video, that's where we're gonna go. Sohcahtoa. Just drill that in your head. Cheesy. It works though. It'll help you memorize sine, cosine, tangent. Okay, that's where sine, cosine, tangent. That's where that comes from. And the quick acronym sine is opposite over hypotenuse, O over H. And cosine A over H, adjacent over hypotenuse. Tangent is opposite over adjacent. And let's take it a step further though, and okay, what does that mean? Well, it really depends what angle you're referencing. And even quick step back before that, I chose to use theta for the angle in these. That's very common in trig. But often when we're dealing with right triangles, like I'm going to do in this video, we use capital letters for angles A, B, and C, and we use lowercase letters for the sides. And my guess, the reasoning for that, it comes back from our Pythagorean theorem, a squared plus b squared equals c squared. Okay, so the side lengths are lowercase letters, and even one more step off of that, in particular, the C in the Pythagorean theorem always stood for the hypotenuse. It doesn't matter how that triangle is drawn, right? Opposite from the right angle is lowercase c. And we always denote the capital C to be, and I know you can't really tell my C's apart, but the capital is the angle, right? The capital is the right angle, and the lowercase is the hypotenuse. So the hypotenuse for cosine and for sine is always the side length directly across from the right angle. Okay, it's the longest one. Even if you don't have a visual, if you don't have a picture, it's the longest side. So that leaves us with the adjacent opposite. How do you know which is which? It really depends which angle you're talking about. So if I'm looking at this angle here, okay, that's my angle A. Sometimes they'll put it there, sometimes they'll put it in here. Okay, either way, that's my angle A. Then lowercase a, we are referring to the one across from it, the opposite. So if angle A is the angle I'm looking from, then lowercase a would be over here, which is the opposite. Then that leaves B, so lowercase b has to be here, and therefore capital B, the angle B, would be a opposite from that. Right? If I'm going from this angle, the opposite side would be lowercase b. So therefore, in this first triangle I drew without any numbers involved, if I was talking about what is the sine of A, then it's the opposite over hypotenuse. It would be lowercase a over lowercase c. Okay. Recall that sine is a trig function. It's a ratio. It's by definition in a right triangle opposite over hypotenuse, but we'll see later it doesn't have to necessarily be a triangle. We have other ways to view this as like the unit circle. Okay, is another, but they're all intertwined. Okay. Well, what if I wanted sine of B then? Well, now, right, from the angle B, opposite is the lowercase b, and hypotenuse is still C. Okay. Let's go ahead and do two more. Like, what if we wanted cosine of A? Okay, cosine is adjacent over hypotenuse, so the adjacent means next to, right? It's touching. So from this angle A here, both C and B are adjacent, but we know C is the hypotenuse automatically. Therefore, side B is the adjacent when we are using A as the reference angle. So we have B over C. And let's go ahead and just do tangent while we're at it. Tangent of A, opposite over adjacent. So opposite would be A, adjacent is B. right? Now, if I put values in there for A, B, or C, or even the angle values, right, we could define all of these things. So let's do that. We had a special triangle, and I created a video with the special triangles where this is a 30-degree angle, and therefore I know that this B is a 60-degree angle because the sum of the three angles in a triangle add up to 180, and we have a right triangle, so one of them is 90, so a 30, 60, 90. Right. So we had talked about the special triangles, how that fit in with the unit circle, how we got these ratios, and they're all kind of intertwined. I'm going to stick with the fact that we'll pretend this is the unit circle, and therefore, if I told you C is 1, in all reality, you can find all the sides, but taking some baby steps here. A is going to be 1/2. Okay, we know the relationship of the hypotenuse to the shorter side here. Whatever the hypotenuse is, we divide it by 2, and we got 1/2. And then we also had B, which is square root of 3 over 2. We multiply by that side length by square root of 3. Now I'm going to take a side step really quick and relate this back to, like, where did all that come from, right? The unit circle. In the unit circle, we'll look at quadrant 1 only. We had a 30-degree angle, and we had quickly shown how to get all these coordinates for the 30, and then we had a 45, and we had a 60. Quick side tangent, we had, and these points at 0 and at 90 you should know, but this is 1, 0, and this is 0, 1. And then we had talked about they're all over 2, but you do square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and then square root of 4 over 2, which reduces to 1. And the y values would be opposite of that. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And looking at this 30-degree, right here, from this angle here, this is my opposite, which is the y value, which is 1/2, which is what I put. The x value here, right, that's the length of the x, square root of 3 over 2. Maybe I should use a different color. The x value, that's the adjacent. And then because we are dealing with the unit circle, the radius, the hypotenuse, is 1. Okay. So the sine of a 30-degree angle, whether we are looking at a triangle or the unit circle, it doesn't matter. We have the opposite 1/2 over the radius over the c, which is 1. Anything divided by 1 doesn't change, so sine of 30 is 1/2, which, notice on the unit circle, is the y value. Okay, on the unit circle. Sine of b, now we're looking from the 60, we could go here, right? We could go back to the unit circle, or now that we have these values, it's b over c. We have square root of 3 over 2 over 1. So let me go and write this out. Sine of 60 is square root of 3 over 2, again over 1, which is just square root of 3 over 2. Cosine of 30, because again, a is my 30, right? I could come over here and look on the unit circle. It's going to be the x value, but adjacent over hypotenuse, b, square root of 3 over 2 over 1. Right, here's my adjacent over hypotenuse. And one thing to point out here, notice sine 60 cosine 30, we get the same. Anytime we have complementary angles here, they add up to 90, sine and cosine will have the same values. Okay, so sine of 30 is the same as cosine of 60. Okay, if I knew the sine of 80, that would be cosine of 10. Okay, those are complementary functions. Moving on, last we have tangent, a over b. That is a tangent of 30 is a 1/2 over square root of 3 over 2, a over b. So one way we could divide fractions is just multiply by the reciprocal. So we get 1 over root 3 because the 2's cancel. But rationalized, you get square root of 3 over 3. Okay. While we're at it, we looked at the 30s and 60s. Let's do the 45s really quick. So this, looking at the second triangle, I'm getting a little cluttered here. That'll be all right. If I called this angle A, it really doesn't matter which one. Then opposite of it is little a, B, little b. Okay, but for a 45, 45, 90, I purposely drew it like this because you could see the way I drew it doesn't really fit in this unit circle. Right, here's the 45. But I just got to picture it flipped, and the reason I did that is it doesn't matter with these triangles if it's spun, right? Like this last one, this, depending on the angle, maybe it is in the unit circle. I'm just showing you it doesn't matter which orientation the triangle's in. Naming the values A, B, and C are the same. Okay. So if C is 1, okay, if C is 1, then we're on the unit circle. And I already know these other two lengths are going to be this and this. They're the same, right? Because it's 45, 45, 90, which means these two legs are the same length. So if I wanted sine of 45 degrees, now it really wouldn't matter if I'm looking from A up here or B, right? Because they're both 45. And we get opposite over adjacent, which is square root of 2 over 2 over 1. I'm sorry, opposite over hypotenuse. Again, it didn't matter which one I was looking at. They're both little a and little b are both square root of 2 over 2. So we get square root of 2 over 2. Okay, cosine is going to be identical because it's adjacent over hypotenuse. But they're both adjacent and opposite are both square root of 2 over 2. Tangent is opposite over adjacent. Well, if they're the same, right, anything divided by itself is 1. All right, I'm going to go ahead and mark this because I am getting a little messy. I apologize. That was all the work for, we'll call that 2. This was all the work for 1. All right, and last we'll go ahead and let's do a different color. I don't know, purple. We'll call this problem 3. I'm going to make up some values here. Let's just do like, I don't know, let's say this one is actually 62 degrees. Okay, and then all I knew, I don't know, how about this is length 10? All right, problem 3. So that's all it's given. 62 degrees and length 10. So what if we wanted the hypotenuse? What if I want to know what is C? So I'm looking at 62 degrees because that's angle given. And I could, in fact, use the fact that 3 triangles add up to 180. And I could find that this is 28 here, right? But I'm just going to stick with the 62 because it really doesn't matter. It's the same amount of work. I need to look from that angle, what 2 sides do I have? Well, I have this side of 10, which is opposite, right? From that 62, this is the opposite. And then C, we already know, is the hypotenuse. So looking at what we have, what we're trying to find, the trig function that uses the opposite and the hypotenuse is sine, right? Sine. It's always sine of some angle, so sine of 62 degrees is opposite over the hypotenuse, which we don't know. So depending on the problem and what exactly they want, we're solving for the hypotenuse. I put H, I guess we should have put C because that's what it's labeled as, right? Well, if I want to solve for C, it's in the denominator. I need to multiply both sides by C. So C times the sine of 62 degrees equals 10. But we're solving for C, so also divide by that sine of 62 degrees. And from there, you would just plug it in your calculator. Make sure you're in degree mode, right? Because we're doing 62 degrees. And see what you get. And I'm plugging this in really quick and calculator. And depending how they want you to round, we'll just do 1 decimal. It's about 11.3 units, whatever we were in, inches or feet or whatever it is.